All right, let's do this. This is Elliot with your GRE question of the day. And I'm sure you've just been waiting with bated breath. It's probably the most fun thing you're going to do all day. Let's be honest. Let's get excited and let's get Pythagorean on the quant section. Here's the question we are looking at today. I'll suggest that you pause the video and give yourself a few seconds at least to read through and see what's familiar, what you recognize about this question right away. If it seems familiar enough, give yourself an extra 90 seconds or so to jump in and try solving it, and then you can unpause and we'll walk through it together. All right, this one says in the coordinate plane, the distance between 0, 0, the origin, and point A is the square root of 50. Which of the following cannot be the coordinates of point A? So what do we recognize in the first few seconds reading this problem? Hopefully the same word is coming to all of our minds, and that is geometry. Okay, we have some geometry happening in this question. We know that's the case every time that they mention the coordinate plane. And what do you do if you're going to try to interpret or simplify a geometry question before you get started doing any math? Exactly. We're going to draw a picture, hopefully fairly intuitive, but nonetheless brilliant approach to dealing with making sure that you wrap your head around what a geometry question is asking you the right way and go about solving it in hopefully the most efficient way possible. So here we have the coordinate plane. We know they're talking about this guy, right? The horizontal and the vertical line that go together. And the origin we know is 0, 0. That's where they cross. And we're just talking about some distance. We don't know how far it is. We could just call it right there to point A. And of course, we don't know the coordinates of point A. That is what the question's asking us to find out. So we'll just call it X and Y for now. Now, you might be thinking either that you're just a little stuck, you're not sure how to go ahead solving for what the coordinates of that point could be and whether or not you need to know how to calculate this distance that the question is calling the square root of 50. What I hope you're not thinking too much about is distance formula. It's a little bit more involved. You're probably not actually going to need to plug in that whole all that madness. I think it's too complicated a formula for when you're trying to go quickly on the GRE. And the truth is, it's not going to be the simplest way to solve this problem. So let's set that aside. And really important tip, maybe one of the big takeaways, there's going to be so much value in our GRE question of the day today, but some of it certainly lives in the fact that if you're given distance on the coordinate plane, the best way to think about that is probably thinking of that distance as the hypotenuse of a right triangle. Okay, so it didn't seem like we had a right triangle question in front of us just from reading it, but we definitely do. That's the best little bit of interpretation to make. Because if I draw a little vertical line in here, I can now say, well, that distance along the horizontal line, the x-axis, is that equal to the value of that x-coordinate. And same thing, y, the value of the y-coordinate is going to be equal to that distance along the y-axis, that horizontal line. Okay, hopefully that makes some good sense. And maybe a lot of you know where we are going to go next. What is the most important formula, maybe in all the geometry for the GRE, but certainly when we're dealing with right triangles, Pythagorean theorem. And most students I work with, they know that x squared plus y squared equals the hypotenuse squared, or a lot of times we think of it as a squared plus b squared equals c squared, but they don't always know how to use it effectively to get points that they deserve. But since we're now looking at a right triangle, hopefully everybody will agree that what drawing this picture helps get us to is that the squares of the two legs, so x squared plus y squared, should be equal to the hypotenuse squared. In other words, that distance they gave us of the square root of 50 squared. And don't be too confused. I see a lot of really bright and well-intentioned students trip over this, but it is true that the square root and the square sign, they're opposites of each other, basically. They cancel each other out, right? So what is the square root of 50 squared? It's just 50. Okay, hopefully everybody's feeling really good about that. So catch your notes up if you need before I erase this, or you'll jump back in the video. But let's now get to this simpler interpretation that we've done. What this question is basically saying is, if we call x and y the coordinates of point A, then x squared plus y squared should be equal to 50. All right, halfway home. What is going to happen next? Are we going to set about now doing some algebra and isolating these variables and getting to x equals some value, y equals some value, and picking those values out from the list of answer choices? No, we're not. You're exactly right for a couple of different reasons. One is we have a quadratic equation here. Quadratic meaning we have stuff in our equation raised to a power higher than one. We have squares in our equation, makes it a quadratic equation. And the reason that's important to recognize is that we know most of the time a quadratic equation could have more than one solution. So straight ahead linear algebra that we're used to doing might not work. The other thing is we have two variables, and this is really critical for test day that you know, if you have two variables, you need at least two linear equations in order to be able to solve for those values. One equation, like the one we're looking at here on our screen, can only get us the value of one variable. So in any case, what you should have a clear indication of is we got to do something else besides just some steps of isolating a variable algebraically in order to get the points here. And most of the time when we need to do something else besides the straight ahead mathematical solution on the GRE quant section, what do? Yes, that's right. We're going to evaluate the list of answer choices. What a brilliant room full of GRE students we have with us here today. Kudos. Okay. And if you didn't know before, now you do. Evaluating that list of answer choices is going to be a great way to go about this. In other words, we'll go through our list, we'll plug the coordinates in each answer choice in for x and y, square them and add them up, right? Do the math in the equation and see which one or which ones come out to 50. So this is where we have to agree about one more little trick in this question, that it says which of the following cannot be the coordinates of point A. In other words, if we plug in coordinates from an answer and it does come out to 50, what we're saying is, since that equation does work, those could be the coordinates of point A. And if they could be the coordinates of point A, then on this question, that's actually the wrong answer. Okay, so if we're looking for which one cannot be the coordinates of point A, then we're hoping one and only one of this list of answers will do x squared plus y squared, and it will not equal 50. If that sounds okay, then we can go ahead and get started with a little bit of math here. And if you are feeling good about what's going to happen next in these next couple steps of evaluating the list of answer choices, then pause me again and give yourself 30 seconds or so to run through the list, and then you can unpause me to confirm that you've done this correctly. Otherwise, let's all walk through this together. So what I'm saying is, in answer choice A, x and y, 1 and 7, I'm going to want 1 squared plus 7 squared to be equal to 50. Little bit of math. We know the 1 just stays 1 when we square it. 7 squared, everyone ought to know by test day right away that that's 49. Knowing the squares at least up to 10, maybe 12. If you're really good at memorization, maybe up to like 15 squared is 225, could be worth knowing. You don't want to worry too much about memorizing lists because none of this is certain to come up on test day, but there's a good chance. So you could save yourself a little bit of math by knowing some of these squares cold. Certainly, I'd want you to know 7 squared is 49. And 1 plus 49, everybody can see pretty easily that does, in fact, equal 50. So one more time, because here x squared plus y squared does equal 50, 1 and 7 could be the coordinates of point A and make that distance of the square root of 50. So answer choice A is actually incorrect. We can eliminate it on this basis. Making some good sense? I hope so. Let's give ourselves a little bit more playing space, and we'll take a look at answer choice B next. Okay, everybody should be playing along at home by now in your own scratch paper. So here the coordinates are 2 and 6. 2 squared makes 4, and 6 squared makes 36. Does that equal 50? No, it does not. Okay, so because here x squared plus y squared does not equal 50, worth repeating, is very easy to make mistakes here. So if you are making those mistakes, don't at all be discouraged. That's why we're reviewing this one in such detail. 4 plus 36 is not 50, so those cannot be the coordinates of point A. Now, on test day, you'd want to feel good about the logic here. There's one and only one answer on the list that will not make 50. That proves that this is the correct answer. So with the clock ticking, you'd want to have the confidence on test day to just pick answer choice B and continue on your merry way, scoring all the points. But for today, really good practice to reinforce the logic here. We'll continue to look at the rest of the list and make sure that we see everything going on in this question. Answer choice C says that 5 squared plus 5 squared should come out to 50. Those are both going to be 25s. And that does add up, right? 25 plus 25 does make 50. Once again, because these here we do satisfy x squared plus y squared equals 50. These could be the coordinates of point A. So the answer choice C is not the correct answer in this case. Next one is going to be really good to look at because they threw another little radical at us. So very good to confirm this is going to make sense for everybody, that it would be 6 squared plus the square root of 14 squared. Will that come out to 50? So 6 squared, 36. And another chance to repeat and confirm, the square root of 14 squared leaves us with just 14. Those two symbols, signs, whatever, they basically cancel each other out, and we're just left with the number under the radical. Does 36 plus 14 make 50? Yes, it does. So again, that satisfies the equation. So 6 and the square root of 14 could be the coordinates of point A, meaning on a cannot be question, this is the wrong answer. Let's do it one more time, as I'm sensing confidence is growing here, which is great. That's what we're doing here today, is building some confidence for test day. Answer choice E, that's not what we're looking for. Answer choice E says that 7 squared plus 1 squared should equal 50. And again, that's 49 plus 1. And does that equal 50? Most assuredly, it does. Okay. And let's also add in here, by test day, even if you were going through to answer all these choices for some extra confidence, you would want to see that answer choice E is the same two coordinates as answer choice A. They're just reversed, right? Since in the equation, we're just adding x squared plus y squared. You know from your order of operations that you can add in any order and you get the same result. In other words, x squared plus y squared is always the same as y squared plus x squared. So you should actually probably have known that answer choice E was going to work out, because we had already tested answer choice A and that one worked out. And we could have saved ourselves a couple seconds of math. All those seconds are precious, as we know, on the GRE Quant section. But in any case, here where we're practicing really getting these ideas dialed in, we can see it in front of our faces now. Again, one more time, this does satisfy x squared plus y squared equals 50. 7 and 1 could be the coordinates of point A, so answer choice E is incorrect. Huzzah! Answer choice B was correct. And we see a really important takeaway here, that most of the time when we get when we get geometry on the GRE, it actually ends up still being algebra. And when we don't see an easy way to proceed, just doing some algebra, a mathematical solution, evaluating the list of answer choices directly is usually our best plan B. Great job, team. So I hope you'll join me back here tomorrow for another GRE question of the day. And of course, if you have any questions, feel free to reach out, or if you're just looking for a little bit more help, you can message me on Instagram at Herson Test Prep. And in the meantime, happy studying.